And it's time for the G3A quiz. So take out a paper and a pencil and number 1 through 19. When you're done with the quiz, you can find the answers at hamwhisper.com under the exam answers page. Just find the G3A section of questions. And with that said, let's get started. Question 1. What can be done at an amateur station to continue communications during a sudden ionospheric disturbance? A. Try a higher frequency. B. Try the other sideband. C. Try different antenna polarization. Or D. Try a different frequency shift. Question 2. What effect does a sudden ionospheric disturbance have on the daytime ionospheric propagation of HF radio waves? A. It disrupts higher latitude paths more than lower latitude paths. B. It disrupts signals on lower frequencies more than those on higher frequencies. C. It disrupts communications via satellite more than direct communications. Or D. None, because only areas on the night side of the Earth are affected. Question 3. How long does it take the increased ultraviolet and X-ray radiation from solar flares to affect radio wave propagation on the Earth? A. 28 days. B. Several hours depending on the position of the Earth in its orbit. C. Approximately 8 minutes. Or D. 20 to 40 hours after radiation reaches the Earth. Question 4. What is measured by the solar flux index? A. The density of the sun's magnetic field. B. The radio energy emitted by the sun. C. The number of sunspots on the side of the sun facing the Earth. Or D. A measure of the tilt of the Earth's ionosphere on the side towards the sun. Question 5. What is the solar flux index? A. A measure of the highest frequency that is useful for ionospheric propagation between 2 points in the Earth. B. A count of sunspots, which is adjusted for solar emissions. C. Another name for the American sunspot number. Or D. A measure of solar activity at 10.7 centimeters. Question 6. What is a geomagnetic disturbance? A. A sudden drop in the solar flux index. B. A shifting of the Earth's magnetic pole. C. Ripples in the ionosphere. Or D. A significant change in the Earth's magnetic field over a short period of time. Question 7. Which latitudes have propagation paths that are more sensitive to geomagnetic disturbances? A. Those greater than 45 degrees north or south latitude. B. Those between 5 and 45 degrees north or south latitude. C. Those at or near the equator. Or D. All paths are affected equally. Question 8. What can be an effect of a geomagnetic storm on radio wave propagation? A. Improved high latitude HF propagation. B. Degraded high latitude HF propagation. C. Improved ground wave propagation. Or D. Improved chances of UHF ducting. Question 9. What is the effect on radio communications when sunspot numbers are high? A. High frequency radio signals become weak and distorted. B. Frequencies above 300 MHz become usable for long distance communication. C. Long distance communication in the upper HF and lower VHF ranges is enhanced. Or D. Long distance communication in the upper HF and lower HF range is diminished. Question 10. What is a sunspot number? A. A measure of solar activity based on counting sunspots and sunspot groups. B. A 3-digit identifier which is used to track individual sunspots. C. A measure of the radio flux from the sun measured at 10.7 centimeters. Or D. A measure of the sunspot count based on radio flux measurements. Question 11. How long is the typical sunspot cycle? A. Approximately 8 minutes. B. Between 20 and 40 hours. C. Approximately 28 days. Or D. Approximately 11 years. Question 12. What is the K index? A. An index of the relative position of sunspots on the surface of the sun. B. A measure of the short-term stability of the Earth's magnetic field. C. A measure of the stability of the sun's magnetic field. Or D. An index of solar radio flux measured at Boulder, Colorado. Question 13. What is the A index? A. An index of the relative position of sunspots on the surface of the sun. B. The amount of polarization of the sun's electric field. C. An indicator of the long-term stability of the Earth's geomagnetic field. Or D. An index of solar radio flux measured at Boulder, Colorado. Question 14. How are radio communications usually affected by the charged particles that reach the Earth from solar coronal holes? A. HF communications are improved. B. HF communications are disturbed. C. VHF-UHF ducting is improved. Or D. VHF-UHF ducting is disturbed. Question 15. How long does it take charged particles from coronal mass ejections to affect radio wave propagation on the Earth? A. 28 days. B. 14 days. C. The effect is instantaneous. Or D. 20 to 40 hours. Question 16. What is a possible benefit to radio communications resulting from periods of high geomagnetic activity? A. Aurora that can reflect VHF signals. B. Higher signal strength for HF signals passing through the polar regions. C. Improved HF long path propagation. Or D. Reduced long delayed echoes. Question 17. At what point in the solar cycle does the 20-meter band usually support worldwide propagation during daylight hours? A. At the summer solstice. B. Only at the maximum point of the solar cycle. C. Only at the minimum point of the solar cycle. Or D. At any point in the solar cycle. Question 18. If the HF radio wave propagation, or skip, is generally good on the 24 MHz and 28 MHz bands for several days, when might you expect a similar condition to occur? A. 7 days later. B. 14 days later. C. 28 days later. Or D. 90 days later. And finally, question 19. Which frequencies are least reliable for long-distance communications during periods of low solar activity? A. Frequencies below 3.5 MHz. B. Frequencies near 3.5 MHz. C. Frequencies at or above 10 MHz. Or D. Frequencies above 20 MHz. And that's it for the quiz and lesson 12. And that was a bit of a long lesson. But for the answers for the quiz, go to hamwhisper.com, look under the exam answers page. You'll find it under the G3A section of questions. And until next time, this is Andy, KE4GKP, saying 73, and I hope to hear you in there soon.